My guest today is Sudhir Hasbe, the Chief Product Officer for Neo4j. Sudhir, thanks so much for taking the time to join us.
Thank you, Jason, and looking forward to conversation today.
Let me set just a little bit of our context for our discussion today. We all have learned and continue to know the importance of data for every federal mission. At the same time, the challenge for every federal agency is there's a lot of data. It can be hard to find. And how do you use that data to gain those valuable insights? The challenge, of course, is to break down data silos to make better data-driven decisions. And this will obviously lead to improved efficiency, better cost effectiveness for each decision, and really each mission area across government. So how can agencies unify and mobilize complex data? How can they improve mission-critical decision-making through better data? Well, that's where my guest comes in. So here, let's jump right into it. Why is it important? And I think we know why, but what are agencies doing? Why do we keep talking about this vast amount of data and how to manage it, how to get better about using it to drive really decisions?
That's a great question, Jason. And, as you mentioned, the data size in organizations, like all our agencies and for all the programs, is only growing. And this size and complexity of the data has been growing over many, many years. And that's because the world is becoming more connected and more complex. And the data only reflects the world and the missions as well as the programs that are running in the agency. So as these things become more complex, the world becomes more connected, the amount of data that we are collecting is becoming bigger. And it is also becoming, as you said, siloed, and it's also becoming harder to analyze and understand. And I think the most important thing for all of our agencies is to figure out what is important in that data, figure out what's unusual, like what are the anomalies, because parsing through terabytes or petabytes of data is not an easy thing. And then figuring out what's next out of the data, what actions can you take, is the real challenge for our agencies and everybody. So basically, it's important to go ahead and have all of this data structured in a way that you can parse through it, understand those three things, which is what's important, what's unusual, what's the next action I want to take out of it, and make it accessible to everybody within the agency.
You make it sound so simple, right? What's important? What's unusual? What's my next action? But unfortunately, it's getting harder because, as you said, there's so much data. Let me start with the silo piece. Do you still see silos across organizations? I thought we got past this years ago. I thought we understood we have to have information sharing, right? We got to connect the dots. How many times have we heard that? But are silos creeping back in?
I think the challenge in agencies and various organizations is the data is always siloed. What we mean by that is, yes, we may be combining the data into a single platform. We may be making it accessible and shareable with each other, but do you really understand the relationships between the different types of data that you have? Can you go ahead and understand, take for example, the cyber threat, or if we're looking at cyber intelligence and cyber threat, there is data that's coming from the web assets, and you need to understand where threats are coming there. You need to understand how, the networks are designed, how different users are using the platforms, which accounts have access to what. There's a lot of complexity and different data assets. And it's not just about, can you just break the silo, put it into a single system, but can you build, for example, a graph on top of it so you understand the entities, but also their relationships. So you can then figure out how to make better decisions on top of it. That will let you make more better decisions. So it's not just having more data, break down the silos, but also understand the relationships between these data assets is critical for all the agencies.
I appreciate the fact you define silo, because I think what people think when they hear silo is takes us back to the mid 2000s, early 2000s, late 90s, where, oh, well, you have your database and I have my database and they don't interact and talk. And now we have these big data lakes and we have data oceans and data space, right? Because there's so much data out there. But really what you're talking about when you talk about silos is how do the two pieces talk to each other, interact? That is a very difficult challenge for a lot of agencies because they're not familiar with how to use data from point A and point B and point C to get to point D. Why is that so difficult? Is this just the next stage of understanding and managing data, or is there something else that's missing?
Yeah, let's take one example and then we can go into details of the challenges that come together, right? Like, and I've spent before joining Neo4j, I spent 5.5 years in big data space. I led the product management for data analytics at Google Cloud, and I saw this everywhere. And I see this in large organizations like our agencies, defense and all the different places. Take supply chain, for example. When you think about supply chain, think about the supply network that's being built to move items across the whole global locations. And if, let's say, US Army uses Neo4j to track all of their supply networks and do the supply chain analytics. It requires bill of material, which are like, what are the different products that are there? How are they interlinked with each other? That comes from a different database where the products are actually in different places, locations and all. That may come from a very different place. And then ability to go ahead and bring real-time data as well as the historical where the products are. That's a very different kind of a data set. And then using all of that to provide more risk analysis. Like now you have to run algorithms and say, hey, what is the impact of, let's say, a hurricane in one location, and what happens to when the supply chain gets disrupted in that particular because of that activity? That requires knowing everything before, after, what alternatives are. So as we think about making these complex decisions, you have to get data from different places and break the silos, but also understand what the relationship between all these different data assets is. And you have to do that in large scale and in real time, and then apply algorithms to figure out how to do better on that. So I think that is what we mean. It's, you're absolutely right. A while back, we used to talk about, can two databases talk to each other? Now we are talking about, no, can two data assets collected from multiple databases can come together, understand the relationship between them, and then make a better decision on top of it.
I think your example of the hurricane is great because we see this, all of us see it when there's a hurricane that hits New Orleans, a lot of gas refineries there. All of a sudden they go offline, they get slowed down, infrastructure gets damaged by a hurricane. All of a sudden gas prices in Maine or North Dakota or wherever rise because the supply chain is impacted. Do you get a sense that agencies are starting to see those connections more because of things like my example or your example of the hurricane, but also now throughout the pandemic, right? Unfortunately, we got to continue to talk about the pandemic, but that also was a huge disruptor to the supply chain.
No, absolutely, yes. And we see this happening in different agencies. We see different use cases using technologies like graphs to map out the physical world into a software world and do more of these analysis. And so we are seeing this lots in various agencies where agencies are becoming better and better, not just collecting, but also understanding. Another example I will give you is global tax organizations use graph technology like Neo4j to go ahead and do analysis of compliance analytics, right? Like imagine all of United States, 300+ million people, who is filing taxes, who is not, are they filing accurate taxes? What happens when people who are evading taxes, but there are different transactions that that are happening. So if you can correlate people, taxes, who is claiming which type of taxes, and if you can correlate that data with all the other transactions, now you can easily figure out where the tax evasion is happening. And so again, a completely different example from a weather part, but the whole tax compliance is a great example of a complex world, lots of data, lots of people, lot of transactions coming together to help agencies tax agencies to make sure that they're getting the tax compliance.
You mentioned the silos. We mentioned how agencies are overcoming those silos and kind of breaking them down. There are other obstacles too that I think they have to keep in mind and try to overcome. Are you seeing where are some of the other areas you're seeing that agencies still are struggling to make sense of their data? Where are some of those other roadblocks that whether it's people, process, or technology?
I think there are various areas where we need a lot more improvements. I would say access to this data. So like the first step is break the silos, get the data. Second step is, can you make sense of that data, relationships and all. The third thing I think is like democratization of data and insights within the agency. Like, do you have access to the right insight at the right place for every individual who's making the decision? And I think there is a lot more work we can do in that regard, and where newer technologies can help a lot, right? Like there is the whole wave of generative AI technologies coming in, which can give you natural language kind of an interface to your agency data. And you can, like, if you had all the data mapped, let's say in a graph, leveraging generative AI technology to use natural language on that and ask questions and get answers, and just democratize access to that insights will actually help everybody within all the agencies and within all the programs. So that's, I think, one area there is a lot more opportunity for everybody to work on. The other area that I do believe is there are still lots of complex, like in a lot of large agencies, there are a lot of complexities in them, where I think we can leverage technologies like graph to solve a lot of problems that may be there. One thing that comes to my mind is just the complexity of our veterans affairs. Like in that area, think about it, it's tracking assets, people, services, the backlog, the records, the access to providers for our veterans. Like there is so much complexity, so much data. It's a massive organization. So I think like in that kind of an environment, there may be more opportunities to get efficiency by bringing all of this data assets into systems like graphs and get better efficiency across the whole agencies. But just one example that came to my mind when you asked me where we can do better, I think.
Sudhir, it only took you about 12 minutes to get us to talk about generative AI, so that may be a good job. You held back, I know. But in all seriousness, I think one of the big obstacles is understanding how those new and emerging technologies like generative AI, like natural language processing and more can fit into the data and how to use it. Because there's also the concern that, okay, am I using the data in the way that I intended it to, or am I going to open a Pandora's box of sorts that could put me in a tough spot? And then there's the cyber concerns too. How do you see customers, and as you talk to agencies, how do you, again, I'll go back to striking that right balance?
Yeah, no, I think first of all, see, there's always a wave of technologies that come in, and we all know it's going to have profound impact on our environment, right? And generative AI is one of ChatGPT actually normalized and made AI understandable for everybody, right? And that was a great thing. But again, like some of these technologies, you have to be you have to grow with them. You have to learn where they are good, where they are not. The way I think about it is it's math versus English, right? So when we went to school, we learned math. This was computer science, computer programming. It gives you math. It always gives you the same answer, accurate answer. But generative AI is English language. It's creative. It answers questions based on some data and facts, but it was built to generate content, right? So therefore, it can hallucinate. It will basically give you answers that may not be accurate. So as agencies look at these newer technologies, there are a few things to worry about. One, data privacy, data security, making sure that you're not using passing data that you don't want to open up. How do you make your secure data? Second, how do you make sure you're getting accurate answers? So this is why grounding the generative AI technology with your knowledge that you have in the agency is super important. Like if you have a knowledge graph, you can make sure that the answers are accurate and coming out of the knowledge you have built, not just with generative. So bringing these things together is really valuable. And the third thing I would say is the most important thing I always suggest is start small, use few use cases, and implement it and learn from it and figure out how you want to do it. So once you have learned with few smaller use cases, then scaling across the agency is possible and more doable. So I would take one program, figure out what you learn from that, and then expand it across for the whole agency.
Like any new technology, like anytime folks are getting into things that they're not quite familiar with, start small, learn, continue to grow. So here, let's take a quick break. When we come back, we'll continue our discussion. You're listening to the discussion, Innovation in Government, sponsored by Carahsoft on Federal News Network. Welcome back. You're listening to the discussion Innovation in Government, sponsored by Carasoft on Federal News Network. I'm your host, Jason Miller. My guest today is Sudhir Hasbe, the Chief Product Officer for Neo4j. Sudhir, we talked in the last segment about some of the obstacles, and you brought up this idea of start small, understand what you're doing, learn from those lessons, get bigger. But you also brought up some of the challenges around silos and data privacy and security and those things you have to worry about. Another big challenge that I want to maybe talk to is creating data analytics silos and how easy that can be for agencies, because you're doing data analytics and I'm doing data analytics, but we're not doing it together. So we're missing that opportunity to take advantage of each other's learnings. Maybe talk a little bit about how agencies can avoid creating those new silos.
Yeah, no, I think that's a great point. And also my early recommendation on like start small. And if you start small in multiple places and create silos of that data elements and do different kinds of analysis in silos and not think broadly, that is also a problem that happens. And, you know, when you want to move fast within agencies, let's say program A, program B, they both want to go ahead and move fast. They will put some analytical systems in place and you can do well there. But I think one of the key things to like also for agencies to think about is how do you build like a common, like, platform that we can get all the data across all of the programs across the agency and then have a shared analytics platform, like put everything in graph technology or something where you understand the relationship between all of these entities, understand how they interact with each other and have a single place to like, analyze all of that data. I would actually go a little further than that. Like whenever you also have an agency to agency sharing or like, you want to do some analysis of data across different departments like agencies or programs, it's important to have that common analytics layer, which allows you to share information with the relationships and entities and all that. And that's where graph technology works really, really well, where it can bring all of these different things together. I will give you one example. A lot of our users in different places, like one of our common use cases in basically intelligence analytics, which is like, different police departments wanting to go ahead and analyze, solve cases. They basically have like different police departments have different data. Then you have like some specific, in a particular case, you will get some data from, let's say, a different agency, and then you merge all of that together and understand. So having that like, graph layer that allows different agencies to interact in that shape only for temporary period or for longer period is a great way of solving that problem. But +1 to having some strategy that brings the whole agency-wide analytics in one platform so you can all look at all data at the same time.
So here, I'm going to take us maybe a whole step back in our conversation. And I think you've mentioned this several times, so I want to make sure folks understand. You keep saying these graph layers and graphs. I will admit, when I hear graphs, I want to go to my graph paper. I want to go back to elementary school and dot my, this is going up as that goes down. But I know you're meaning more than that. But maybe just give us 30 seconds of when you say graph layers, what do you mean?
Yeah. So graph, like, there are various ways of storing data and like, like in using data sets and databases and all that. Graphs are a specific way where you basically focus on what are the key entities within your agency and their relationships between them. For example, you can have people each other, people can be related to a specific product, people can be related to like, they have reviewed some products, they have like, if you're looking at that. So another example is supply chain. If you think about supply chain, it is billions of products that you have, and each product may be related to other product. And to get one product, you need to go ahead and procure this other product so that it's available. So that relationship, storing information of not just there are billion products and there are other things, that relationship between products in a real simpler way is what graph technology does. Another great example is bill of material. If you look at Lockheed Martin, their manufacturing, right? When they manufacture for different missions, they have massive bill of material. If you need to build a rocket, imagine how many millions and millions of parts are required. All parts are linked to each other. And if you want to know what happens if this part is missing in the whole process and you need to procure it, and what will be the delay for the whole program, you'll basically be able to analyze that. So graphs are a mechanism of, say, storing and analyzing information in form of entities and their relationships and then dependencies across them.
I appreciate that explanation. I think, again, we just want to be clear though. So folks, you keep saying graphs. What do you mean? So thank you for that, because I think that's key. And let's go down that pattern, because through this analytics, through these graphs, you can see those patterns, you can understand those relationships. When you talk to agencies, do they kind of make that connection? Oh, so if X happens, that has Y, Z implications. Are they starting to understand that more?
Yeah, they are. Like, and this is where we see like 6 out of 7 intelligence agencies in United States use graph technology and Neo4j for these use cases, right? Like when you have things, think about when you have data in rows and columns, Excel, everybody has seen that data. It's easy when this data is small to do row, column, I can understand. Imagine now billions of data points and millions of relationships. It's super hard in that format to understand. But if you have that same thing represented as billion points related to other billion points, and now you want to do, for example, you want to figure out like money laundering and what's happening across the globe and who is sending money in like fraud rings, you can easily on a visual level in graph see, oh, this entity started sending the money to these thousands of people, they sent to other 1,000 people, and finally it landed with this, like, bad agency that we are all tracking in intelligence. Now that is really easy to do when you store it as like, entities, relationships, and graphs. And that's exactly the kinds of use cases you can solve with graph technology. And agencies are using that, like, for various different use cases. But intelligence agencies, this is super critical when they start looking at it.
That same challenge is even, you could do it on the other side of it, right? You brought up the idea of stopping terrorism or looking for bad actors or however, but the opposite is also true. Where does the grant money that HHS gives out, how does that flow to the community, and understanding, oh, that grant money went to this state, which went to this organization, went to this person or these set of people, and now their lives are better. So I think that's a great example of understanding those relationships.
Absolutely. You nailed it. And also like grant money, but think about HSS, like our Health and Human Services, the grants that they're giving to different research organizations and the impact of that research organization on the, let's say, different drugs that are coming out and how that has been saving. So this is like a complex view, right? Like I think that I think is the biggest value for the whole agency, is like ability to track complex web of information, which is all interconnected. And when you look at rows and columns, you will see, oh, I gave this grant to this agency, but you don't know what they did with the next one and the next one and next one. And the ability to traverse that graph is an important value that you can get.
The other piece that I just want to touch upon is this also opens the door to, if you will, what else can we do with this data? How else can this data drive better mission decisions? Are you starting to see some discussion or some questions around what else can we do? Where else can we go with this? What's next?
Yeah, I think that's a great question, right? As I was saying, as you get this relationship and data mapped out in form of graphs, there's a lot more like, analytic risk analysis. Like what happens if some stuff goes out? We talked about the weather case, but imagine with COVID, suddenly there were few factories that were shut down in China, or something went wrong and your supply network gets disrupted. If you wanted to do what if analysis of that and run an algorithm, it's much easier when you know the distribution of the next n number of entities that are going to get impacted with that across the agency. And this becomes super critical in supply chain. It's really important in intelligence, threat analysis. One of the other big use cases this is really relevant is cyber. And so if you look at the cyber security and cyber threats, one of the best examples is the Peraton threat board, which many of the agencies use. That actually is built on Neo4j's graph technology. And it allows you to do this complex threat analysis based on all the different events that are coming and what the relationships are. So I think that's a great example of what more you can do. Those are from like different kinds of use cases and all. But I think as the newer technologies come together, one of the big things I am a big believer of is in democratizing data and insights. And I think once you have this knowledge captured about different entities and making it more and more accessible to the users within the organization is going to be like, game changer. And this is where natural language interfaces to knowledge graphs are going to become more and more interesting. We already have some of the agencies as well as some of the key players looking at that supply, the manufacturers that supply to the different agencies are looking at those technologies to democratize insights with us.
As you talk about this use of graphs, the use of understanding the data, the relationships, breaking down the silos, is this also going to put more pressure on the workforce? Do you see a workforce that needs to evolve into understanding how to make those connections? You talk about democratizing data earlier. That always sounds great until I don't know how to use that data. I don't understand what this data means. Is that another concern that kind of comes up across agency customers and private sector customers?
Yeah, I think there is always when you look at information in a different way, I think naturally there is some kind of training and evolving the knowledge and expertise is required. Till the time you're in Excel taking at rows, columns, you know that it's such a natural experience in Excel. When you look at graphs and how the graphs can help you solve different problems, of course, you want to be able to be more familiar with the technology, with the tooling that's available. And we do work with a lot of agencies, training them and making these technologies accessible to them. But this is why I was saying and then as the technology evolves, having more natural language interface to the graph data makes it more accessible to more people within the agency. So I think that's why I'm super passionate and also excited about that side of the technology evolution.
And I think the natural languaging piece, as you brought up, is really important because, again, well, I'm not a data scientist. What do I know about this? No, you can make it easy, ask a question, and hopefully you can get a pretty good answer. And
the other one more area, I think, Jason, I will add there is, graph technology and taking the data, mapping it into graphs it's great to have this explicit relationships, right? Like, for example, you're able to go ahead and store all these different entities, their relationships and all. And with more and more newer technologies, now you can also get the implicit relationship. So you can take, for example, you can take your knowledge articles or the parts data that you have for every part within a program or mission. And then you can basically have some unstructured documents that you may be storing for it, like parts manuals and all. You can convert that and also store it in graphs. And now you can search on top of that data. So it's not just like you have structured entities and relationships, but these documents, this unstructured data, images, those can also be part of the same data assets. And you can then get benefit out of both like structured and unstructured data that agencies have. And what comes to my mind is, imagine like Lockheed Martin, which has like massive manufacturing side. They have bill of material that's stored in graphs, but the parts manual may not be there yet. Now you put the parts manual along with bill of material, it unlocks so many different ways. Like I want to go ahead and fix some problem that's there in particular program. Hey, how do I do it? Oh, just search for the documents, figure it out, and then what parts do I need along with it? You can solve that problem. So I think that's the other big part of the whole system, which is like implicit and explicit relationships, bringing them together to solve problems.
Well, solving the unstructured and structured data challenge has been something we've talked about for years and years and years. So it sounds like there's some hope at in the future, some light at the end of the tunnel. But unfortunately for us here, we're out of time. So let me thank my guest. Sudhir Hasbe is the Chief Product Officer for Neo4j. Sudhir, thank you so much for taking the time today.
Thank you, Jason.
I'm Jason Miller, and you've been listening to the discussion Innovation in Government, sponsored by Carahsoft on Federal News Network. For more on this discussion, visit federalnewsnetwork.com and search innovation.